get started. Today we are going to talk about the force system resultants. And last time also we talked about the force system resultants, but last time we discussed the moment of force regarding the scalar formulation. This time we are going to discuss the vector formulation. And in order to understand the vector formulation, it's important to review some mathematical background. So in order to review mathematical background, we are going to show you what does it mean by the cross product. If we are going to have vector A and vector B, then the cross product of vector A and B will yield new product, new vector, which is C. So C vector equals A vector cross B vector. And the direction of that new vector is going to be perpendicular to the plane AB. And in order to know the direction, you need to use the right hand rule. So in the right hand rule, you are going to use your right hand, and you are going to move your fingers here. You are going to curl your fingers so that they are going to start with vector A towards vector B. And then you are going to notice that your thumb is going to direct to the direction of the new vector. So C equals vector A cross vector B. And since it's a vector, it means that it has magnitude and it has direction. In order to calculate the magnitude represents the length of that vector here, and the magnitude is A times B sine theta. So the magnitude of the C vectors equals the magnitude of A, the magnitude of that vector, times the magnitude of B vector sine theta. Theta is the angle between vector A and vector B. And similarly, or also we can know the direction of the C vector. We said that the direction of C is perpendicular to plane containing AB. So if I made a plane from AB, then the new vector is going to be perpendicular to that plane. And we are going to say that the C vector equals A vector cross B vector is going to equal the magnitude times the unit vector. So if you know the unit vector here, if you multiply it by the magnitude, you are going to calculate the C vector. Then we want to talk about the laws of operation. So mathematically, how we are going to deal with the cross vector. The first point here, we are going to learn that the commutative law is not valid here, which means that A cross B does not equal B cross A. In other words, if you are going to change the order of the vectors, here I have A, B. If you are going to put B, A, the result is not the same. And the reason for that, if I have vector A and I have vector B, I'm going to use the right hand rule. My fingers here, I'm going to curl my fingers so that they are going to move from A to B. And if you are going to try to do that, you are going to find out that your thumb is going to be directed in that direction here. But if you are going to say that B cross A, it means that I'm going to use my right hand and curl my fingers so that I'm going to start from B towards A. And if you are going to try to do that, you are going to find out that the direction is down here. So the direction is opposite to that one, which means that the A cross B is going to equal to minus B cross A. So you cannot say A cross B is the same as B cross A. But you could say A cross B equals minus B cross A. The second point is about the associative law. The associative law, when you multiply the cross product by a scalar. So here I have a scalar, small a, times A vector cross B vector. You can say that that amount equals to A times A vector cross B vector. Or you could say that it equals A vector cross A small b. Or you can put it like that. Also, you can put the scalar here at the end. So the cross product, it obeys the associative law. And the third point, we are going to talk about the distributive law. So also the cross product obeys the distributive law of addition. So if I'm going to have vector A cross vector B plus D, then you could say that that amount is equivalent to A cross B plus A cross D. So I can distribute the vectors here by multiplying by B and D. So we have 3 points in order to deal with the cross product. The first one, the commutative law is not valid. The second point, I can use the associative law. The third point, that I can use the distributive law. Now, we are going to get back to our three-dimensional system. Here we have I, J, and Z, and K. I have I, J, and K, the unit vectors. I is a vector, J is a vector, and K is a vector. What if I want to get the cross product of I cross J? I have I and I have J. We said that the cross product of A cross B, we are going to have new vector which is perpendicular to the plane of AB. This time here, instead of A, I'm going to have I. Instead of B, I'm going to have J. So here is the plane of the cross product. Then the answer, as you might have guessed it, the K is the new vector as a result of the I cross J, because K is a vector which is perpendicular to the plane of I, J. So if I'm going to use the right hand rule, I'm going to put my right hand, I'm going to curl my fingers here so that they are going to move from I towards J. And you are going to find out that the new vectors K is going to be perpendicular in that direction. So what if I want the cross product of J cross I? So first we need to know the cross product of I cross J. What if we want the cross product of J cross I? So here I'm going to use my right hand, but this time I'm going to move my fingers so that I'm going to curl my fingers so that it's going to move from I to J. If you are going to do that, you are going to find out that the vectors, your thumb is going to direct down here, which means that the result, it will be minus K. And if you do remember, when we were talking about the commutative law, we say that A cross B equals minus B cos A. So we are going to say that J cross I, it will give us minus K, while I cross J, it will give us positive K. Then, so here I cross J equals K, and here we have J cross I equal minus K. So let's try to use or try to get the value of J cross K. So now I have a plane. This plane here is made from J and K. And I want to get the cross product of J cross K. So here my plane, and I'm going to apply the right hand rule. I'm going to put my right hand so that the fingers will curl from the I towards the K. If you are trying to do that, you are going to find out that the thumb is going to be directed in the I direction. So J cross K, it will yield I. So I have J cross K, it will give us I. What if I moved, or what if I want the cross product of K cross J? So this time my fingers is going to be curled so that it's going to be moved from K towards J. You are going to find out that your thumb is going to be directed in that direction. It means that you are going to find minus I. So if you reverse the process, you are going to find out that K cross J equals minus I. And the same thing, it could be used if you are going to move from K towards J, and also you are going to get the product of I cross K. So if you are moving from K to I, so you are going to move from K to I, then the cross product is going to yield J. If you are going to move from I to K, you are going to get minus J. So how I'm going to differentiate between those? If you are going to move from I to J, which means I cross J, you are going to get positive K. If you are going to get the cross product of I cross K, then you are going to get positive I. If you want to get the cross product of K cross I, you are going to get positive J. But if you are going to move clockwise, you are going to get the cross product of J cross I, you are going to get K. If you want to get the cross product of I cross K, you are going to get minus J, and so on and so forth. What if I want to to get the cross product of I cross I, like this one? I cross I, it will give us 0. And the reason for that, I cross I, if you want to get the magnitude, we are going to have the magnitude of I, which is 1, and the magnitude of I again, which is 1, and the angle between I and I, which is 0, and sine 0 is 0. That is why the value is going out to be 0. And if the magnitude is 0, that means if you want to get the cross product of the same unit vectors, which mean that I cross I, or J cross J, or K cross K, the outcome will be 0. So now we have good background about the cross product, and that process is going to help us in order to deal with the moment of a force in the vector form. So we have vector A and we have vector B. We could put vector A in Cartesian form, right? So in order to express vector A in Cartesian form, we are going to have AX, the component in X, followed by the letter I, plus the component in Y, followed by the letter J, plus the component in Z, followed by the letter K. Similarly, you can express the B vector in the Cartesian form. We are going to get Bxi, the component into X, plus Byj, the component in Y, plus Bzk. Here, Bz is the component of the vector B in the Z direction. And here I'm going to deal with the cross product. That is why I show you how to that is why I showed you the law of operation, or the operations law. So how I'm going to deal with those vectors here? I have vectors cross other vectors. We said that the distributive law is valid here. So I'm going to say that AXI cross BXI, then AXI cross BYJ, and then AXI cross BZK. So I'm going to distribute that part here to that part and that part and that part, because the distributive, the cross products obeys the distributive law. And I'm going to do the same thing for that part and that part. So for this part, as a result, I'm going to get 3 terms. This one cross that one, this one cross that one, this one cross that one. Then this part here cross that part, and cross that part. And finally, this part cross that part, cross that part, cross that part. So I'm going to have 9 terms. So IXI cross BXI, and also from the associative law, AX and BX are magnitudes. So I can put them here, and I'm going to only put I cross I. And similarly, I can do it for all the rest terms. So now I have 9 terms. I need to simplify those terms. Here, we talk about the what will happen if you want the cross product of the unit vectors. And for that term here, I cross I is going to equal 0. So that part, it will gone. Then here I have I cross j. Say that I cross j, it will yield k. So instead of this, I'm going to get the unit vector k. Here I have I cross k. I'm going to get minus j. And I have here j cross I. I'm going to get minus k. And here j cross j, I'm going to get 0. Here I have j cross k. I'm going to get I. Similarly, here I'm going to get j and minus I and 0. So now I have k and minus k, and I have I and minus I, and I have j and minus j. I want to simplify the equation here. So I'm going to say that here I have, I'm going, of course, to start with the I. I have I here minus I, and I have I here, which is positive. So I'm going to take I as a common factor. This part is going to be positive, and this part here is going to be negative. Similarly, I'm going to do this for j and k. For the k, here I'm going to put minus for a reason. You are going to know it after that part. We're going to put minus here because we want to get the value by using the determinant. So here I'm going to put minus j. If you are going to put minus j, that means this part is going to be positive, and the other part, which is here, is going to be negative. Then plus k, regarding the k, I have that part, which is positive, and I have that part here, which is negative. So now, if I have vector A and vector B, if I want to get the cross product is going to be like that. Like you can see here, it's very difficult to memorize that equation, right? So if you are like me, you cannot memorize that equation, then we are going to use the determinant in order to know that equation here. So this equation here, it could be written as determinant, 2 by 2 determinant. I'm going to say that I cross B is going to be the determinant of I, J, K, AX, AY, AZ, BX, BY, BZ. AX is here, AY is here, AZ is here, BX is here, BY is here, and BZ is here. And I have the unit vectors I, J, and K. And also, if you don't remember how to get the determinant, I'm going to explain it here. So if you want to expand a determinant, first you are going to start with the element I. You are going to say that the expansion of that part here of the element I is going to equal I, of course. Then you are going to ignore that part, and you are going to ignore that part since you are dealing with I. And you are going to multiply this one here by that one. So you are going to multiply AY times BZ. Then you are going to put minus and then multiply AZ minus BY. So you are going like that, like this sign. You are going to start from here and finish here. The same process is going to be done for the element J. Here we have J. You are going to ignore the row here and the row there. And you are going to put minus J. So you have to remember this. We need to put minus. And then we are going to multiply AX times BZ minus AZ minus BX. So you are going to go like that. Then for the element K, again, the element K is located here. So you are going to cross that row and that column. You are going to say that the expansion of the element K equals K. Then you are going to say that open the bracket AX times BY minus AY minus BX. So now I come up with the equations which is similar to that equation here. So if you cannot memorize that equation, you are going to get the determinant for that matrix. So here we're going to get the first part by expanding the element I, the second part by expanding the element J, and the third part by expanding the element K. So you are going to get the same answer. This is the first part here, this is the second part here, and this is the last part here.